So for this video is about alkanes and cycloalkanes. So for contents, first is the introduction to alkane, the nomenclature of alkane, constitutional isomers of alkanes, relative stability of isomers alkanes, source and uses of alkanes, drawing Newman projections, conformational analysis of ethane and profane, the cycloalkanes, conformations of cyclohexane, drawing chair conformation, monosubstituted cyclohexane, disubstituted cyclohexane, the CIS or cis-strand stereoisomerism, and lastly is polycyclic system. In organic chemistry, the cycloalkanes are the monocyclic saturated hydrocarbons. In other words, a cycloalkanes consists only of hydrogen and carbon atoms arranged in a structure containing a single ring, and all of the carbon-carbon bonds are single. Cycloalkanes, alkanes are termed saturated because they incorporate the maximum number of hydrogens possible without breaking any carbon-carbon bonds. They are also a members of a larger class of compounds referred to as aliphatic. Cycloalkanes have two fewer hydrogen atoms than alkanes because another carbon-carbon bond is needed to form the ring. Cycloalkanes are drawn in a simple polygons in which the sides represents the carbon-carbon bonds. It is understood that each corner of polygon is a carbon atom bonded to two hydrogen atoms. So for the introduction to alkane, ang alkanes isa siya ka-organic compound na nag-consist sa tibuok single-bonded carbon and hydrogen atoms and lack any functional groups. So any of numerous saturated hydrocarbons, especially any of series of open chains or hydrocarbons such as the methane and butane kay ginatawag na paraffin, and it is a saturated hydrocarbons. By saturated hydrocarbons, it means alkanes have a single hydrogen and carbon atoms in their chemical formula. So here are the example to identifying the parents. First step is choose the longest chain. Step 2, so kapag ang dalawang chain is already complete, you need to choose the chain with more substituents. Next is about nomenclature of alkanes. So alkanes are named by dropping the ending of parent and adding is indicated with a number. IUPAC rules for alkane nomenclature. First is find and name the longest continuous carbon chain. Identify the name groups attached to the chain. Next is number the chain consecutively, starting at the end nearest a substituent group. Lastly is you need to designate the location of each substituent group by an appropriate number and name. So here are the example to identifying the naming substituent. First step is identify the parent. Second step is identify all alkane substituents connected to the parent. And then last step, you need to name each substituent using the names in table 4.2. So next is about the constitutional isomers of alkanes. So mao ni siya ang duha ka molecules nga the same sila og molecular formula, however, different sila og structural formulas or the bonding arrangements are known as constitutional isomers. So here are the examples for identifying the naming complex substituents. So first step, kailangan sa nimo i-identify ang parent. Second step, place the order on the complex substituent going away from the parent chain. And then last step, you need to treat the entire group as a substituent on a substituent. Next, the relative stability of isomeric alkane. The heat of combustion is inversely proportional to the stability of isomeric alkanes. That is, more stable alkane isomers will give off less heating during combustions, while less stable alkane isomers will give off more heat because of weaker CH bonds and lack of branching. So here is the examples of assembling the systematic of an alkanes. First step, identify the parent, identify the name substituent, number the parent chain, and assign a locand to each substituent. Arrange the substituents alphabetically. Next is the sources and uses of alkanes. Alkanes are more important raw materials of chemical industry and the principal constituent of gasoline and lubricating oils. Natural gas mainly contains methane and ethane and is used for heating and cooking purposes and for power utilities. The first four alkanes are used primarily for heating and cooking and are also used for power generation in some countries. Example for assembling the name of bicyclic compounds. So first step is identify the bicycloparent and then indicate how bridgeheads are connected. Identify the name substituent. Third, number the parent chain or start the longest bridge and assign a locand to each substituent. And lastly is assemble the substituent alphabetically. So for drawing Newman projection. Newman projections are drawn by looking directly along a particular bond in the system and arranging the substituents so that they are equally spaced around the atoms. At each end of that bond, projection useful in alkane stereochemistry visualize the conformations of a chemical bond from front to back, with a line presenting the front atom is circle representing the back carbon. Example of assembling the systematic name of alkanes. Identify the parent, identify the name of substituent, number the parent chain and assign a local to each substituent. Arrange the substituent alphabetically. So for conformations analysis of ethane and propane. In the eclipse conformation, the CH bonds on the front and back carbons are aligned with each other with the hedral angles of 0 degree. In the staggered conformation, the CH bonds on the rear carbon lie between those on the front carbon with the hedral angles of 60 degrees. The two conformations of ethane and eclipse conformation and staggered conformation. So here are the example for how to identify the constitutional isomers. Constitutional isomers have different names. So kapag duha ka compounds have the same name, then the same lang gihapon ang ilang compound. The conformational analysis of butane. Generally, butane has 4 conformational isomers, which are fully eclipsed, gauge eclipse, and anti-butane conformational isomers. And also, the anti-conformation is the lowest energy conformation for butane. Here are a quick example for drawing Newman projection. First step is identify the 3 groups connected to the front carbon atom. Second step, you need to identify the 3 groups connected to the back carbon atom. And lastly is assemble the Newman projection from the 2 pieces obtained in the previous step. The cycloalkanes, the class of hydrocarbons having a ring-like structure. The ring is formed due to their saturated nature. And they have 3 compounds of alkane present in the structure which helps them in forming a ring inernally. The physical properties of cycloalkanes are similar to those of alkanes, but they have higher boiling points, melting points, and higher densities due to the greater number of London forms that they contain. Here are the examples for identifying the relative energy of conformations. The conformations of cyclohexane. Examples of common conformations of cyclohexane include the boat, the twist boat, the chair, and the half-chair conformations, which are named based on the shape that the cyclohexane molecule assumes in them. The 2 extreme conformations of cyclohexane are chair and boat. Here are the example for drawing a chair conformation including their 5 steps. So for drawing chair conformation, To draw a basic chair conformation, start by drawing two sets of parallel lines and connect them like seen above. After you have drawn the chair conformation, the next step is to number the carbons. The cool thing about this is that it doesn't matter which way you number the carbons. To determine the chair conformation stability, add up the A values for each acyl substituent. The lower the number, the more stable it is. Here are the example how to draw acyl and equational positions. The monosubstituted cyclohexane. A substituent group in a substituent cyclohexane, such as the methyl group in a methyl cyclohexane, can be in either an equatorial or an axial position. These two compounds are not identical, yet they have the same connectivity, so they are stereoisomers. Because they are not enantiomers, they must be diastereomers draw. Here are the example of drawing both chair conformation of a monosubstituted cyclohexane. The substituted cyclohexane. One of substituents must necessarily be acyl and the other equatorial, regardless of which chair conformer is considered. For drawing both chair conformation of substituted cyclohexane, you need to follow the three steps. First is using a numbering system and determine the location and configuration of each substituent. Second, you need to place the substituent on the first chair using information from step 1. Lastly, you need to draw the second chair skeleton and place the substituents using the informations from the step 1. The CIS or C-strand stereoisomerism. Cis-trans isomers exhibit a type of stereoisomerism where the atoms have different spatial arrangement in three-dimensional space. In the field of organic chemistry, cis isomers contain functional groups on the same side of the carbon chains, whereas the functional groups are on the opposite sides in trans isomers. Geometric isomerism is a type of stereoisomerism where rotation around the is restricted, such as in the case of a double bond. Here are the example for drawing the more stable chair conformation of polysubstituted cyclohexane. There are three steps. First is using a numbering system, determine the location of configuration of each substituent. Second, using the information from the step 1, draw a both chair conformation. And then last step, you need to assess the energy cost of each acyl group. The polycyclic system. In the field of organic chemistry, a polycyclic compound is an organic compound featuring several close rings of atoms. Primarily, carbon if two or more atoms are shared between more than one ring, then the system is said to be a polycyclic. Here are the quick examples of drawing the more stable chair conformation of polysubstituted cyclohexanes. First, you need to use the numbering system to determine the location and configuration of each substituent. Second, you need to use the information from step 1, draw the both chair conformation. Lastly, you need to assess the energy cost of each acyl group. This is Honey May Babdog Kiawit from BS Biology, and thank you for watching.